everyone, and welcome to another edition of Ask Me Anything presented by Mosier Consulting. I'm your host, Angel Leon, Mosier's HR advisor. And in this week's episode, we will be talking to a leader in the STEM arena, a professor of electrical and computer engineering at Rose-Hulman Institute, none other than Dr. Carlotta Berry. Dr. Berry is a professor in the Department of Electrical and Computer Engineering at Rose-Hulman Institute of Technology. She has a bachelor's degree in mathematics from Spelman College, a bachelor's degree in electrical engineering from Georgia Institute of Technology, a master's in electrical engineering from Wayne State University, and a PhD from Vanderbilt University. She is one of a team of faculty in ECE, ME, and CSSE at Rose-Hulman to create and direct the first multidisciplinary minor in robotics. She is the co-director of the NSF STEM Rose Building Undergraduate Diversity, or RoseBUD, program and advisor for the National Society of Black Engineers. She is also the president of the technical editor board for the ASEE Computers in Education Journal. She has taught undergraduate courses in human-robot interaction, mobile robotics, circuits, controls, signals, and system, freshman and senior design. Her research interests are in robotics education, interface design, human-robot interaction, and increasing underrepresented populations in STEM fields. Dr. Berry, thank you so much for being with us today. It is an honor to have you on Ask Me Anything. How are you?
I'm great. How are you doing?
I'm doing excellent. Thank you very much once again. This opportunity to talk to you is great. I know that I'm looking forward to talk to you today, learn more about you, what brought you to the robotics and engineering field, what are your passions, and how do you see the world of robotics and engineering evolving?
So one of my biggest passions is STEM education, and that's kind of how I got to the robotics as well. When I was an undergraduate student at Georgia Tech, one of the biggest challenges is there's not a lot of women and not a lot of people of color in engineering. So although I had aspired to only be an engineer, I decided to become an educator because I felt on that side of the podium, I could work better at diversifying STEM. So the robotics came later. I actually started out as a controls engineer. A controls engineer is someone who designs products and systems to work in a certain way. It doesn't actually have to be a robot involved at all. But my internship and my first job was at Ford Motor Company right outside of Detroit in the River Rouge in Dearborn. And an industrial manufacturing facility has a lot of robots, as well as a lot of needs for controls. So that's when my passion for robotics was born. Although I had taken a robotics class in undergrad at Georgia Tech, they at the time did not allow the undergraduates to touch the robot. Only the grad students did. So we looked at it behind some plexiglass and we wrote the code, but we didn't get to touch the robot. That was no fun.
Yeah.
So once I was in the manufacturing facility and I could touch the robot and I could design the line logic to make the conveyor belt talk to the robot. It was a windshield plant, so it made windshields, but picked them up and moved them and put on the mirror button. Then I was able to see how exciting it was to do that. But no matter how much engineering I did, I was always mentoring undergraduate students. I was still tutoring K through 12. And that's when I was like, I gotta be an educator. As much as I love engineering, I gotta be an educator. And one thing I found is robotics is a great hook for everyone from 9 to 99. Everyone gets excited about a robot because robots are cool. So if I want to diversify STEM, I could use the robot as a tool to do that. So although I think robotics is cool, I think one of the greatest things about it is the fact that robots are multidisciplinary. I can show people math, science, physics, coding, human-robot interaction, social psychology, social science. Wow. All of that is somewhere in the robotics field, right? So you tell me what you're interested in, and I talk to you about what about robotics you might be interested in doing. So that's what led into my passion about robotics.
So Dr. Berry, tell me, what was your first success in the field?
So as I previously mentioned, one of my biggest disappointments in undergrad was the fact that I was learning about robotics and it was a lot of book smarts, but I didn't really get to do a lot with a physical robot. And so this is one of the, I've had several successes at several levels. I like to say I'm an intersectional nowhere STEMinist because my engineering is not traditional electrical or computer engineering or controls. It's an intersection of computer science, robotics, engineering, mechanical, etc. So one of my successes was when I designed my first robotics course with an actual robot that students got to touch. It made the class more difficult, but we immediately discovered that they were up to the challenge. So if you give students something that they're excited about, they'll work all through the night I may design the assignment to take 3 hours, but if it takes them 15 to get it, which is typical in engineering school, they're willing to do that because they're so excited about robotics. So that was my first education success, is designing a hands-on learning robotics course that eventually had a waiting list that became so popular.
Wow.
My first professional success was when I was at Ford Motor Company, as I alluded to. And in automotive manufacturing, the line is everything. If the line goes down, your life comes to a stop until you get it back up, because minutes equal dollars. And I was able to look at the code on the robot and figure out what was going wrong and why the line was down. So the first time a professional success in the field happened, I was excited about that. If we think about grad school, which was later in life, it's when I transitioned from industrial robotics to mobile robotics, which is what I still do to this day. And I was able to design an interface, which is basically like a GUI, like widgets and things in Windows, where people could remotely drive my robot using an interface I designed in order to navigate and find things in the environment. Because I wasn't one of those kids who started out in engineering. I always wanted to be a school teacher, probably all the way through high school. I was just going to be a high school math teacher. So I was never one of those little kids who was in the garage with dad, taking the TV apart and changing the oil on the car. I had a single mom who was a kindergarten teacher. So when I realized that me and this non-traditional pathway could still achieve the same levels of success as those more prototypical type engineering types, if you think Dilbert and Sheldon, then those were my successes. And that's why I say I'm here to change the face of engineering and show people that you do not have to be super duper smart or a super nerd to be good at engineering. You just have to be curious, creative, and innovative.
That's exactly what I was just thinking. Creative, just be creative. I want to go back because you mentioned something at the beginning of this question. As you as an educator and how you build that robot. I want to go back and I want you to tell us, how did your students react? What was their first reaction when you first showed them what you had built and what they were going to be working on? Because I got to say, I mean, even as an adult, like if somebody just came into a room and told me, okay, you're going to learn with this robot that I just created, my jaw would just drop. But I want to hear from you, from the educator in you. How was that reaction?
It was great. I will say that Rose-Hulman, being a hands-on school, almost every class has a hands-on component, which is kind of rare. And it's because Rose-Hulman only has 2,000 students. So giving a lab for most of the curriculum is not a big deal, as opposed to like a larger school, say a Purdue, is a little bit harder because you're going to have 200, 300 students in class. So they were excited about the robot, but I sometimes get more excitement when I go to populations outside of Rose, because I also do virtual robotics workshops. And I've done in-person robotics workshops for Girl Scouts and other organizations like that. And I think they get a little bit more excited because seeing something like that is kind of rare for them. Whereas our Rose students, they're expecting when they walk in a room, they're going to tinker with something. They're going to pick up a soldering iron. They are going to pick up a screwdriver. They're going to take something apart. One of my biggest complaints is my robotics class is multidisciplinary. That means I have students in there, mechanical engineering, electrical and computer engineering, computer science and software engineering. My favorite story I tell my students is, these robots have to be used for every class for several years. You mechanical engineers, get off my robot, because they're the main ones who will go back to the dorm room trying to trick out the robot, take the wheel off, add a new gear, leave my baby alone. I tell them to think about the robot like my baby. Don't drive my baby off a table, and stop trying to pull stuff off my robot and put new stuff on. We know you can make and build a better robot, but this robot's got to last me. I can't, change robots every year. But that's how Rose students are. And that's what engineers are. They're kind of like, wonder if I could switch out that sensor. Don't wonder, I need that sensor right where it is for your assignment. Leave it alone. It's kind of like you want them to be curious and creative, but you also need them to like pump your brakes for a minute. We got some learning objectives to meet. One of the biggest things I found is people take robotics class because they want to play with a robot. Well, I still got some learning objectives for you to achieve. So you got to learn how to play in context with what I'm doing.
That is an amazing story. And I got to say, I can relate to the first part of your answer here, because like I said, I know that if I walked into a room where you have your robots, I would definitely be interested in learning. I wouldn't just pick up something because I would be too afraid to actually touch something to break it. So I gotta say I relate to that. So speaking of your passion, how has your passion in the field of robotics and engineering grown over the years?
I think it's grown with my students. I like to say that teaching is like a journey, and you go on the journey with your students. And now that I'm an old fogey in the field, because I graduated with my PhD in 2003, so we're talking what 18 years now,
Yeah.
it's getting to the point that I'm about a generation or so past my students. I now learn from them, and that's kind of cool. So I now give an assignment, and don't tell my students this, but I sometimes will give an assignment that's a little challenging where I haven't had the time to totally figure out if it works.
Oh,
So far, it's never failed. And that's because I was talking about earlier how if it's something you're passionate about, you'll stay up all night. I've had students go and figure out a solution to a problem I gave them that was even better than the one that I envisioned. And they'll come back and they'll say, well, I found this really cool software on this website and I used it. Have you ever seen this before? And I'm like, no, I have no idea. What is that and how does it work? And then based upon that next year, I will integrate what a student taught me into the class.
right.
So that's the cool thing of how I'm now growing as an educator is that I am learning from my students. It's more of an exchange as opposed to me, some people say being the sage on the stage or the chalk talk where I'm just standing up there droning on and on. It's now I tell them, I need the robot to map this environment. This is the way I envision this solution going. But if you come up with a better one, I'm fine with that. So because it's a multidisciplinary class, that's one of the challenges. Mechanical engineering students take a different coding class than electrical engineering students. Software engineers have more programming experience than mechanical engineers. So depending upon where their skill set is, they want to do things a little different. Also at our school, computer scientists don't do a lot of hardware. So when I ask them to do things like wire up a sensor, whereas the ME and EE students are like, okay, the computer science student is like, sensor, wires, I code, so that's the cool thing about robotics is in that class, they all work together. They have to learn to speak each other's languages and help each other with those different parts that are gaps in their curriculum because no one graduates to go work in a silo with only mechanical engineers or only electrical engineers. You have to be able to talk across the cubicle. So with freshmen, because I teach the freshmen, freshmen are really intimidated when they arrive in engineering school. I like to call them 13th graders. They're still high schoolers at heart. They're notorious for calling me Miss Berry because they're so used to their K through 12 teachers. And I'm like, doctor, not Miss anymore, doctor. But the way that we do that with them is you get people excited about something. So one of the questions we'll ask them is, okay, step back from the fact your technical knowledge is brand new. You've been on campus for about a week. Is there anything on campus you've seen that you could have an opportunity to fix? They'll normally start, oh, the air conditioning doesn't work well in the dorm. The line's too long in the cafeteria. That's how you get people to be creative, is you give them a problem. We like to say that innovation and creativity is problem solving in context, right? So you tell me what's broken and I'll tell you how I think I can fix it. And they've come up with some really ridiculous solutions, but that's not even the point. The point is, get them thinking about something they're passionate about. And a freshman in college who's only been there a week, they can run you down everything that they don't like so far. A big one we go over, thinking about Angel's son and my daughter, is one of the questions I'll say, and this is a real story, by the way. One of our freshmen is away from home from the first time, no longer has mom or dad waking him up. So we have a lot of freshmen who are playing video games all night and oversleep their alarm clock and don't make it to class. They miss exams, they miss lecture because mom's not there to pull the plug or wake them up in the morning. Design an engineering solution to help them get to class on time. We've had people design automatic water dumpers. You're going to electrocute them with a shock collar on the bed. You're going to have an app on their cell phone where they got to do 3 calculus problems before the alarm stops going off. Yeah, some of this stuff is ridiculous, but the point, they're becoming creative. So the way to get them creative in context and become more is to think about something that has always bugged you. Who's ever watched as seen on TV and went, oh my God, I could have designed that myself. Yep. And it's because somebody looked this up and said, this is ridiculous. I'm designing a problem for this. My favorite one is the guy that designed the long spongy thing that you squish into the side of your car to keep coins and fries and stuff from falling in the seat. Who couldn't have designed that? It's basically a pillow, right? But yeah, but so things like that, and I actually integrate my diversity work into that same class by showing the students a couple of videos. One of them is from Black in AI that shows someone who designed an AI algorithm that could only track non-brown faces. So researchers had to put on a white mask to make the algorithm recognize their image. This is why diversity is needed on your STEM teams, because if a brown person had been in that room, they could have been like, it doesn't track me. Another one I show them is a video somewhere where somebody designed a soap dispenser that was triggered on skin color as opposed to on distance. I showed that one in class as well. And the guy's trying to get the soap out so he can wash his hands, and it doesn't work until he puts a white paper towel under it. I've actually used some of those automated sinks before. Same thing where I'm like, hello, turn on, turn on. And it's because they never tested it with somebody from a diverse world. I also have done the one on the crash test dummies, where when they first designed those, they used the average male height and size. And nobody ever thought, they put them in these cars and they're like, what if it's a child in the car? What if it's a woman? What if it's a pregnant woman in the car? So I talk to my students about this is why diversity in STEM is needed, because we're designing the solutions to make the world better, but that's for everyone in the world, right? Not the people who are typical. So I do human robot interaction, and I have a robot platform that can be programmed in Arduino, Java, MATLAB, whatever language the students want, because I have different majors and I let them kind of use what they want. I don't really care. But I wanted to make this interface and try to tie what we did in class to my PhD dissertation, but I could never figure out how to make an interface inside of the software. And I had a high school student who showed me that there was an Arduino wrapper in MATLAB and a program called Processing that you could use to design a GUI. And for the first time ever, actually February 2020, right before the pandemic, I had my robotics students use it to make interfaces, and then they did mapping and localization on this interface. And it's so awesome. I have a YouTube video of this on my channel where the students are, whatever kind of creative design I didn't tell them how to make it. I said, just make an interface to do this. So there's like 20 different solutions. They're all cool. And you can see the little dots as they populated to make the map and make the robot move. And it just makes me so proud, because this is them going above and beyond what I ever could do as an undergrad. It's kind of like I have replicated myself, but the superhuman aspect of myself, because they're doing so much more than I ever did at their age.
Yeah, and I got to go back to what you were saying about teaching as a journey. I really like that, the way you're teaching these students nowadays. I mean, because I wish the challenges in developing your creativity, I think you're hitting that right there by providing them with assignments that even you haven't necessarily finished figuring out. So that is so exciting. I mean, what have you received any feedback from your students? How are they? I mean, I know you said not to tell them, but how have they fared since you started using this type of method of teaching?
Well, it's kind of a little bit of problem-based learning, where you learn in real time what you need to do next. So what I tell them is, I give you the robot as an infant, and by the end of this class, the robot may be about a 2-year-old. It can navigate in a world. It can localize in a world, figure out where it is in a world. It can map the world, and it can plan a path. So basically, it's like a baby figuring out how to get to McDonald's by looking at the golden arches, right? So the feedback I get, what I notice is in real time, and this is most classes you teach, students don't always appreciate the value of their learning or can measure the value of their learning until they're no longer in the class. So what I have found is the better feedback comes after they're done or after they graduate. My class is towards the end of the curriculum. We've had students go on to graduate school at Georgia Tech, Stanford, Carnegie Mellon, WPI, Worcester Polytechnic Institute, I believe. I know I'm saying that word wrong. And they'll come back to me and say, your class really prepared me for graduate school, because they get a master's in robotics engineering or they go on to PhD. But they don't realize that until they're an alumni. I've also had students who come to me the next semester and go, I love so much what we did. Can I do research with you? Rose-Hulman is a teaching school, so we don't have a lot of research labs. We don't have PhD students, and we have few thesis-based master students. Mm-hmm. So when you're sparking students' interest so that they want to come and do more outside of their curriculum, you've hooked them.
Yeah.
And so The student I have now decided to go to graduate school. Now that's a win because we're diversifying the profession by drawing somebody to go on to further study who may have originally just said, I'll just get my degree and go be an engineer, which is, there's nothing wrong with that.
Mm-hmm.
But you also want to see some of them come back and give back.
Absolutely. Yeah. Well, I'm just amazed if I agree with you in that a lot of people, and this isn't just your students, but a lot of people don't realize what they're living in the moment is something that is teaching them a valuable lesson, not necessarily for right now, but like you said, for that future. And then, we kind of don't know what we have in our hands until we miss it, until it's gone, right? Until after we've gone through the class and we go to the next step. And then, wow, I didn't realize Dr. Berry was, her teachings are so good. So I really can see that.
Yeah.
So moving on a little bit to what you're currently doing, can you tell us what you're currently working on?
Absolutely. So I am on sabbatical, and my sabbatical was supposed to start in June of 2020, but then, the pandemic happened in March. So I've actually been away from Rose-Hulman since March of 2020, and I won't go back until August of 2021. And my original sabbatical is I was going to be, and I work as an automation engineer for a pharmaceutical company.
Okay.
But then the George Floyd killing happened in May. And right around that same time, Black in the Ivory, the hashtag started trending on Twitter, and a bunch of Black academics started sharing their stories in the ivory tower of academia and looking at things like, marginalization, isolation, implicit bias, racial inequity, etc. And at the time, me and some colleagues noticed that a lot of people posting were from the humanities. There weren't a lot of people in STEM, no engineers, not a lot of scientists. And we discussed it. And what we discovered is because our numbers are so low, people are less likely to post publicly anything they're experiencing in the STEM fields, although we know that research has shown that we do deal with a lot of implicit bias and presumed incompetence, because you would immediately be targeted and identified. Right. Like, I'm the only Black woman faculty member at Rose-Hulman. So if I went on social media and I said, I'm an engineering professor in the Midwest and I'm going through X, people are like, oh, that's Carlotta. We know who that is, right? So we started these we call them Black and X organizations on social media. And the ones that I'm most involved with are Black in Robotics and Black in Engineering. I'm on the organizing committee for both. And the goal of these is not only to address bias and anti-Black racism in STEM, but also to promote awareness, to give recommendations, and to amplify Black STEM. So for example, Black in Engineering has a call to action for being an anti-racist institution. We have published papers on it, articles, we've done lots of podcasts. Obviously it's a pandemic, so everybody Zooms. We've done a webinar, and we are actually being considered for a Diversity and Inclusion Award for the American Society of Engineering Education. We also, for Black in Robotics, have published work on Black roboticists. So one thing is, I look like a unicorn because you see me and you don't see a lot of people like me, but there's really about 25 or so around the country. So to make it easy for everyone, we've published an article about all of us. So if you click on this link, you now see an article about 25 roboticists. And we talk about things like the way to make this more prevalent is to cite them in your work, or to invite them to your classroom to do a talk. And then I have been doing these virtual robotics workshops, actually on Zoom, and we're advertising them on Twitter and Instagram. And so the people who come to those are from every walk of life, right? We do it in Arduino, which I have taught to high school kids. So if you know zero about technology or coding, I can get you up and running as long as you have high school knowledge of science. And due to the success of these things, we have had companies like Amazon, Google, MathWorks, and Teradyne reach out to us to want to partner with us on offering some of these things, because everyone is looking for ways to diversify their workforce, especially their STEM workforce. And another thing we have seen as a byproduct, and this is all a surprise to us, these things were actually started just to address racial inequity. And the fact that companies reached out to us and want to donate to us and ask, how can we help and what can we do? Some of this was a bit of a shock. And so, especially with Black in Engineering, it grew so quickly that we had to immediately start spinning our wheels. And I started Black in Engineering with Monica Cox at Ohio State University and Tahira Reed at Purdue University. We had to immediately get the structure to meet the demand. We did not realize how hungry people were for what we had. Graduate students reached out to us and was like, oh, we're so excited about this. How can we help? How can we support this? So what happened is we had to create a speaker bureau. We started getting requests to speak so much, we couldn't keep up. I went from being asked to speak maybe a couple of times a year to, especially when the pandemic first started, I was getting emails every week.
Wow.
And it got to be to the point that I had to set up like a tier structure of, if it's K through 12, I'll get the grad students to do it. If it's academia, I can get some junior faculty to do it. And depending on what it is, we have to farm these things out because we're glad people are excited about diversifying STEM, but it's just only so many of us to go around. You know, that's why we're doing this, because we're trying to get the numbers up. But in the midst of doing that, we become spread really thin. So our latest thing is, I just don't have the bandwidth to take on one more task. You know, you have to relate it to engineering somehow.
Yeah, no, absolutely. And it is so great to hear about this initiative, because I actually had a question about Black in robotics, because we wanted to know a little bit more about that. And you've provided this insight so far. And it is challenging, obviously, for you all to right now going through the times that we're going through and trying to build up the following, to have more people join what you have already been through, Blacks in robotics and engineering, and just kind of build upon that. So you're basically becoming yourself a stepping stone for others to come in and actually learn robotics, learn engineering, and kind of continue developing where you've been. Because like you said, you've already been in the field for X amount of years. So you've seen a generation kind of grow. But now, you know, given the turn of events recently, now that generation might actually be twofold in the not so near future because of the efforts that you guys are currently doing.
Absolutely. And I will say that I was a first robotics competition judge and judge advisor for several years. And my daughter is a member of the Gamer Girls, which is a first Lego League, and a Vex Robotics team. They were first Lego League, but Vex Robotics is really big in Indiana, as you know. So we transitioned to Vex Robotics a couple of years ago. So because of initiatives like this that have already started in the state of Indiana and in Indianapolis, we are seeing more students coming to college because of their K through 12 experiences in robotics. And that's awesome. And that's exactly why we started the robotics minor at Rose-Hulman, because the students came and said, I want to continue doing that type of work. So Rose-Hulman actually has a first robotics team that is completely mentored by the students, similar to the model of the Purdue First that they have in West Lafayette. And so what we're learning is, like Dean came in with First, they started all these things to get these kids excited and inspired about STEM. You don't want to let that fall to the floor and die when they get to college. You have to continue that model, because, you know, the freshman year in engineering and science is typically calculus, chemistry, biology, physics, which is great. Nothing wrong with any of those. But these babies want to keep their hands on something. So that's why I teach freshman design. So we have integrated robotics, or something that they tinker with, in all of these classes. One of my colleagues has this statement that says something like, I know I'm going to say it wrong, Rose-Hulman is the home where tinkerers come to thrive, or something like that, because you don't want to give up their hacking and tinkering passions once they get to engineering school and they realize you pulled them in with this hook and it was a bait and switch, and now you're just like, go do your calc homework. All of my math professor friends are about to be really mad at me, but the calc's important, physics is important, but you got to keep that thing that pulled them and drew them in as well.
Yeah, and again, I mean, talking about creativity and continuing developing that. So if you've got a high school student that wants to tinker, like you said, you don't want to throw him in that first year class range of taking math. And I mean, there's nothing wrong with that, but you don't want to dwindle down that creativity. You don't want to sort of just push it down, get ready, you know, take your English lit, whatever, in first semester, right? And then just, oh yeah, here's robotics. We forgot. No, I understand that there's a need, and that I think you guys are doing it the right way by just providing that continuum, just making sure that they continue to tinker, they continue to evolve, that creativity doesn't fall down.
Right. We like to say the engineering school teaches you how to problem solve. The technology related to STEM, computer science is probably the worst. It changes so fast that there is no way I can totally teach you everything you're going to have to know for your future career. It's probably going to be obsolete by the time you graduate anyway. So it's more important for me to teach you how to be innovative and creative and problem solve and give you some open-ended problem and go, okay, go search. How do you solve this? That's so much more important than me giving you something, some technology, and then expecting you to still be using that 3 years from now, because it just changes so quickly.
Right. And again, I hate to go back to creativity, but it's so important to continue to nurture that and to continue nurturing those minds so that they in the future can be the Dr. Berries of the world, the leaders that we need to continue pushing the field forward. So that's very interesting. So Dr. Berry, just going back to the Black in Robotics initiative, how can organizations contribute to this type of initiative?
So it's interesting. We had a meeting yesterday, and one of the ways that we have found that people have asked to support us, like I said, we just got funding to continue our robotics workshops. And anything that helps with our outreach at K through 12 or older is definitely welcome. So that's a financial need, but also looking at industry sponsors, right? Undergraduate students coming to work at your company would be another great way to connect with them. A lot of people like to say we have a pipeline problem. I'd love to hire more diverse people, but I can't find them. Well, at Rose-Hulman, the way people get them is you bring them in as an intern, and then you make them love your company so much that they never want to leave. So they graduate, and then they naturally come to work there. So Black in Robotics is actually going to launch its first chapter in Boston, which is where Amazon is, because it's going to be in that Boston area. And so that's one of the ways we're going to try to do it, is if we have these Black in Robotics chapters with industry sponsors, they now can do things like not just sponsor undergrad students, but faculty, right? Faculty are the first point of contact with students. So if I come to your company on a sabbatical, I then will return back to Rose-Hulman. If I have students go, I don't know where I want to enter, let me tell you about a company, right? So I'm on my sabbatical now, and the company I'm working with has made offers to some of my students, because now that I'm there, I'm the first line of attack when they're like, oh, we need to hire a couple of engineers. I know some people, right? So similar with Black in Robotics, make those connections with the organization to not just provide financial support, but also to get people in your industry, give plant tours, have them come there, help us with our outreach activities. So for these that I'm doing one with MathWorks. They're going to recruit some of their employees to come help me with the workshop. So now they're getting face time during the workshop with some of these captive audiences as they teach them about their technology. So now people are learning what does MathWorks sell? MATLAB. What do you use MATLAB for? Controls engineering and robotics engineering. So there's a lot of natural connections, right, with these populations. So we found that a lot of people not only want us to come speak, but do ask questions about how can we connect with you? You're doing some really great things.
I do agree on the recruiting, if you will, the recruiting part, the part of bringing people in, whether that's through an internship or, a sabbatical like what you're doing right now, because that provides you with the opportunity to, number one, show your work, but also, like you said, represent Rose-Hulman in this case, because now you're representing Rose-Hulman students. And so firsthand how good those students are. And so if somebody comes to you and says, oh, Dr. Berry, do you know of any students that might be interested in an internship with us? Yes, why, absolutely. So that is very key. The recruiting part is key. And I cannot say that enough. So,
and I'll give you one more is companies that reach out to me will provide technical things, like they might provide software or whatever. So now when I go back to work, especially if I'm teaching robotics, I'm more likely to use the tools they provided with me because I know how to use them. Right. And they gave me support for those. So now my students are becoming familiar with that technology so that if they go and graduate, it's on their resume and they can go work at that company and go, hey, I used your software for X. So it makes the students look more attractive as well, right? Mm-hmm. Because they've gained some valuable skill sets. One of the main things students like to say is, you're professors because you couldn't make it in the real world, right? So everything you teach them, they always want to ask, is this, people use this in the real world? You guys just are book smarts. This is all theory. This isn't what's really happening in the world. So by going on these sabbaticals, I can come back and go, I just did what the real world engineers are doing. That means what I'm teaching you is relevant, nah. But also by them using the things that I've learned on my sabbatical and it comes back to them, I said, I did this at my company on sabbatical. You're now doing it in class. You are doing real world stuff. You don't have to keep questioning if I'm just teaching you some stuff straight out of a book because I don't know. I can do and I can teach, right?
Yeah, yeah, absolutely. And again, it goes back to you representing Rose-Hulman. It goes back to now you, when you get done with your sabbatical, you can speak to those real world experiences to your students. And that in the end is going to make them better students for a better future for our country and our state. So Dr. Berry, it was a pleasure talking to you today, Dr. Berry. I really appreciate all the knowledge that you have provided to us today. I can't tell you how interested I am in learning more about robotics. I have a 17-year-old in high school right now that I wish would be interested in that. He's more, well, I shouldn't say that. He's interested in electrical engineering. So we'll see how that, translates.
Ooh, have him come to Rose, that's my department. Have him at least consider it. I will say my 12-year-old daughter, although I have stemmed her to death her entire life, is more interested in video games. And I'm trying to get her to be more of a creator than a consumer. So I'm like, you can stick with the video games, but how about we code some video games? How about we become a computer scientist? So I'm okay with video gaming, but let's do it on the creative side, like we've been talking about all afternoon, right? As opposed to just being a consumer. That's where I am.
That's the challenge I have as well with my son. He does like to draw a lot. So I think that's where that engineering part comes, because he loves to draw. But that's the challenge we have right now, which is video games are his focus. He loves video games. So I've told him he could be an engineer in video games. He just has to.
And they have engineering graphics. There's a lot of ways to tie that. We talk about STEAM and STEAM X a lot in the Black and X movement. Science, technology, engineering, art, math, as well as extracurricular, right? So I tell my students, one way to be creative is to walk away from your engineering work sometimes and go over to the drama club. Go down to the pep band, right? Go over to do some dance, or whether it's athletics or other things, because those things you draw on those skills to help you with your STEM skills as well. Keep doing creative activities. Join the robotics team, but let's say there isn't a robotics team in your area. Black Girls Code does online activities. Code.org has online activities. Other websites like that where you can go and learn Scratch on your own as long as you can get to a computer. What if you don't have a computer at your house? Go to the library. Oh yes, the library has really cool stuff. But there's so many STEM activities and outreach activities now. You should be able to find something, especially if you're in the Indianapolis area, because the VEX Robotics, as well as the FIRST Robotics, is still really big in Indiana. Indiana, I think, has the top number of teams, or in somewhere near the top for the country, I think, in VEX and FIRST. So it's kind of like Indiana has become like robotics country for real. But even if there's not something available at your school, there's lots of online activities you can do, especially during the pandemic. A lot of people made their things free. I found a lot of free online things for my daughter to do because people just, slam the doors open and like, oh, come one, come all. They don't have Black Girls Code in Indiana. My daughter was finally able to do those activities because they're now virtual and free online. Well, some of them are. So if nothing else, have them keep doing something. And if you backpedal to when I was little, Legos still work, right? Get them those toys that they can use to make things. My daughter had gears, Legos, snap circuits are really cool if you've never heard of those, snap circuits. But there's lots of things to get kids being creative. Mag formers are good. Those are the magnets that you form to make things. Something to keep their hands moving, which means you got to wrench that iPad out of their hand and you got to get them away from that screen. I know I'm preaching to the choir because my baby is on it too, but that's how you get them being creative. Absolutely. Drawing is a good one. Pencil and paper do it. But anything to keep their hands and minds on activities. So I'll tell you about my robots. I do name my robots. My daughter, ever since she got out of the Elmo phase, has always been Mario and Luigi crazy. So I have several Mario and Luigi robots. But as the years go by, I like to say I have robot graveyards on campus of me whenever the robots die and we get new ones. So I have robots named after The Simpsons, because I have to come up with something. I have robots named after Star Wars characters. I have robots named after, what are the Transformers? So, but my favorite robots right now is I decided to make that a diversity initiative as well. So the robots my students currently use are all named after women and Black robotic researchers. So like Dr. Ayanna Howard at Georgia Tech, Dr. Robin Murphy, Dr. Selma Sabanovic. These are women in robotics or Black people in robotics. And I tell my students, who's your robot named after? That's their first assignment, is they have to go Google and find out who that person is. And this is one way for them to learn about other roboticists like Maya Matari, so Kismet. I also named them after famous research robots, like Kismet is a famous research robot. I have a big dog robot that's named after that, the company that keeps making the robots that people kick and they walk on the ice. And so I am also using my robots to teach them about other things in the field beyond R2D2, which is wonderful. And the robot from Lost in Space, Will Robinson. So we use this to teach them about other things as well.
Dr. Berry, once again.
Angel, thank you so much.
It was great talking to you today. Thank you very much.
Thank you for having me.
And that's our episode today of Ask Anything. We hope you enjoyed my conversation with Dr. Carlotta Berry. We'll be back next week with another episode of Ask Anything presented by Mosier Consulting, your technology partner. In the meantime, please remember to give us a rating and subscribe to our feed wherever you get your podcasts. Until then, so long, everybody.
Go.